everybody, welcome back. This is the first lecture for day 2, and I'm going to go through a bunch of textbook material, then we'll go back into writing stuff. So we can skip this. What we're looking at, yesterday we started the first half of lecture 1, and I went over most of the rudimentary. If you missed yesterday, I went over the most rudimentary areas in terms of creating objects and calling messages to objects, running methods, and we built a person, and we almost built an employee from a person. We'll finish that up today. And we built a couple of iOS applications and had some fun with that. So today we're going to continue. We can skip lecture 2, however, because lecture 2 is on memory management. And in looking at it, you don't have to do any of this stuff anymore, except for you do have to still allocate objects. So the retain, the release, and the memory, the manual memory organization is not applicable anymore. However, we probably, and the reason why I have this lecture up, we probably should at least revisit the concept of alloc and init, because we're going to see this with inheritance today as well. So in terms of, and this is lecture 2, by the way, if you're following along. So the memory management system is semi-automatic. It's always been considered semi-automatic because the programmer does some and then the system does the rest, per se. So a programmer must allocate memory for objects either by using an explicit alloc or using an indirect way of doing it with a convenience constructor. So I mentioned the convenience constructor yesterday, but I want to show you what this means, and I told you I would fill that in. There's no need to deallocate anything. That's why it's called semi-automatic. We allocate, but we don't have to deallocate anymore. In fact, now we're not even doing reference counting anymore. So now we don't even have to worry about most of it. We just allocate and use it. So my suspicion is in the future they'll take away the allocation. Because why do we still need to allocate it? When you think about it, when we don't even do anything with it anymore. Isn't it just syntax? Couldn't it just auto-allocate, and then we'd have completely automatic garbage collection and completely automatic memory management, which is what we get with Java. So C++, we have new and delete, and we allocate, deallocate. Java, we don't do anything. We still use new with Java, but we don't delete objects, and we just create them. So I guess the syntax is never going to go away from Java, so why should it go away from Objective-C? But the equivalence of new in Objective-C is alloc. So what happens when we allocate? So allocation happens when the class method is alloc is applied to the object. Object is a method. It says allocate. Allocate some space for me in memory. And so the message alloc is sent to the class of the requested object. So we go person space alloc, because we're sending a message to the class. And alloc is inherited from NSObject, so we don't actually have to write an alloc method. It just says part of the inheritance. Every alloc creates a new instance equals a new object. So hello world space alloc creates a new hello world object. And so then we just use the object and we run init, usually next on the object to initialize it. So the class creates an object with all zeros in it and returns a pointer to it. So here we have hello world with an asterisk P, which means it's our pointer, and we said hello world alloc. So hopefully this doesn't look so foreign to you. We actually did this yesterday. So this is what we did yesterday when we created new instances of objects that we allocated in main. The pointer P now points to the new instance, and we send a message to the instance through P. So P is the reference. So they call it a reference. Actually, C, C++, they call it pointers. Java is a reference. Objective-C is really a reference. It's not really a memory address. It's not a pointer. So when I think of pointers, I don't know, I think of memory addresses, pointing to memory addressing. This is not pointing to any memory address. We never get the memory address. We never do anything with it. We don't care about it. We just created a reference for it. And it's just a way of getting at this new hello world that we alloced, that we put out there. So you know what reference counting is. If you have an older version of Xcode, you're going to have to deal with this. If you have the current version of Xcode, you don't even have to worry about this. So the older versions and maybe some of the GNU older stuff might actually be working with reference counting because it's not going to be as up to date. My suspicion, it's not going to be as up to date. Why do I say that? The latest version of Xcode and the latest version of iOS is not, it's like maybe a month old. That's when a lot of the changes happened. Then reference counting got taken away. So if you're not working with the latest and greatest, you still haven't figured out that your life is a lot easier if you upgrade. So if you upgrade, your life's going to be a little bit easier. You haven't upgraded yet. You're still working with reference counting. What's reference counting? So every instance has a reference counter associated with it. So we alloc the object, we create a reference, which is our P. So this is the reference P to the object we allocated. Now we're going to keep a counter at how many other objects are using it, or if it's being used at all. We keep a counter, and it's a 0 or a 1. A 1 says it's active, a 0 says it's not active. So we're not really counting, which is kind of misleading, because you'd think it was like a counter, like 1, 2, 3, 4, 5. No, it's a 0 or a 1. It's an on or an off. Is somebody using it, or is nobody using it? If nobody's using it, it gets garbage collected. Garbage collection is a matter of going around the memory and picking the reference counter zeros and removing them from memory, because nobody's using it anymore. This here says someone's using it. We have a reference to it. When the reference goes away, the counter gets decremented. It can get decremented manually by saying release, or we can keep it manually by saying retain, which is where retain and release comes into place. So it counts how many references are retaining the object, or using the object. Retaining is using, and the counter is 1 after the allocation, and it does not count how many references exist. Rather, it keeps track of whether anybody is referencing it. If anybody's referencing it, it goes from 0 to 1. Or from 1 to 0 if nobody's referencing it anymore. So sending a retain message to the object increases the reference counter by 1 to 1, and sending a release decreases it, releases it. You can actually do this. It's legal code. You can put it in your current iOS 7 version. You can write code that retains and releases, no problem. So Apple didn't take it away. They just made it optional. So you don't have to do it anymore if you don't want to do it. So, but if you still want to do it, you have legacy code that's still going to work. So, reference counter equals retain counter. So when the reference counter reaches 0, the object is automatically deallocated. That's what garbage collection is about. A garbage collector goes around, gets rid of memory that's no longer being used. So just like a regular garbage collector in the real world, programmer does not need to deallocate. The counter system does it for you automatically. Programmer only does alloc, retain, and release if they want to do alloc, retain, and release, which means they don't actually have to. We have to alloc, but we don't have to retain and release anymore, which is why I said in the beginning, it's funny we still have to alloc. Why do we have to alloc? You know, we could just do a retain and a release. I mean, why do we don't have to do retain and release anymore? Why are we doing alloc? So it's kind of funny. We'll see what happens in the future. Rules for memory management. The method that does an alloc or a retain must also do a release. If you're going to retain it manually, you have to release it manually. What does that mean? You pick up some legacy code, you kept all the retains, but you got rid of the releases because the compiler's not going to tell you that you need them. So instead, you allocate, 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 you retain, retain, retain. You never release, you're going to run out of memory. Also, sometimes if you have a really heavy application that's running that's taking up a lot of memory on the device, which is possible. You're running a database application, you're reading in a huge file, it's a video or something. If you retain and release manually, you can actually do a better, faster organization of the memory. So you don't actually have to run into a situation in which your app's going to run slow or your program's going to run slow because something's still out there and the garbage collector hasn't come around to release it yet, or it hasn't been released, so the garbage collector's not picking it up yet. So if you want to control the timing, then you do a retain and a release so that you can figure that out. So here you have to retain a balance between the alloc and the retain and the release. If the method does alloc and returns a pointer to the created object, and it must do an auto release instead of a release. So calling the code can do a retain release, but it's not a must that you do that. The auto release is used instead of release if you're going to do in the current system if you're going to do an alloc. Long story short, forget all this stuff unless you want to do it yourself manually. None of this stuff is required anymore. Have you seen we took this line of code out. We didn't even use it yesterday, and we're not going to use it today. But here's our auto release pool. You're going to need this if you're going to write an application that's going to use a lot of memory, and you want to control when the memory is released and when the memory is retained. So an auto release to work, the programmer must create what's called an auto release pool. They're doing that here, and we just called it reference to the object pool. So we can have, pull release, pull drain, pull retain. We can do a bunch of stuff, with the wording and make it sound cool. It doesn't really need to be called pool. We can call it anything we want. So here our NS auto release pool is equal to a NS auto release alloc init. So allocate it, initialize it, copy it into the auto release. So when Coca is used, the auto release pool is created automatically, and the programmer doesn't need to do it. So this is from the Coca library. So remember yesterday I showed you foundation.h, and then I had another project that loaded up said coca.h. Well, Coca is inside of foundation. Coca is the one that's doing the auto stuff for you. So long story short, it's built-in functionality. It becomes part of the auto system or the garbage collector, so you don't necessarily need to worry that much about memory anymore. In the old days, it was not as automated, so it was a bigger deal. So let's go back to these constructors and initializers. So we do an alloc, and then we do an init. And the init we saw yesterday is a form of an initializer that we're calling. Initializer is sort of like a constructor that we get in other programming languages. But the constructors in other languages happen automatically for us. In Objective-C, they don't. So the class, this is a class method, allocates and initializes an object. Programmer is either doing an alloc or an init on the object. So as an example, and now we see this plus here because it's a class level method. Student with name, and we're going to return an ID. We're refreshing your memory on the syntax here. The data type is ID, and the ID is going to be an object that we're going to return. And the name of the method is called student with name. And what we're going to do is we're going to return a student object that's been allocated and initialized all in once. So some people like to do this so that they can create objects in main without having to alloc and init all the time. So you take the alloc and the init, you pull it out of the main source that you're writing, you put it in what's called a convenience constructor, and you just call the constructor. So here you're going to create a student with a name. It's kind of like a constructor in other languages. It doesn't happen automatically, you're still calling the method. We'll see the call to the method momentarily. But here we have a NS name and a GPA, it's a float, it's going to be called GPA. And then we have an ID, which is going to be equal to a new, we're going to call this a new instance, and it's going to be equal to a self alloc, allocate myself, and initialize the student with the name and the GPA, and then return a new student auto release. Don't necessarily need to do this line of code anymore. We don't actually have to do that. We could just return the new student these days. We don't have to return it with an auto release. So whether you're going to be writing convenience constructors, I seriously doubt it. I don't use these because I have no problem writing alloc and init. It's not a big deal. So, and then I know exactly when I've allocated it and initialized it, and then I can run any initializer that I want to run. But some people like to do it C++ style, so they'll write a constructor that allocates and initializes, which is all this constructor is really doing. So they call it a convenience constructor, because it really isn't part of the built-in language. It's more for a convenience that the programmer has created. So essentially here the method sends alloc to self, which is a student object, student class object. Also the method auto-releases the instance because it returns a pointer to the created instance. And then not essential example uses existing initializer. Yes, it does. It creates an initializer, uses this initializer that has already been created inside of the object. So you create an initializer, then you create this convenience constructor that calls the initializer. So it's like what we did yesterday with the multiple initializers calling each other. So when we call the convenience constructor, we do this. So we say ID student is equal to student, student with name. We're calling the constructor student with name, and we're giving it Johnny and the GPA 3.8. Well, what we're really doing is calling this method. The method is student with name, and it has a name and a GPA. And this method is doing the alloc and init and returning the object. And I think this is more work than just creating an alloc and an init and running the initialize alloc and init right there in main. So if you miss the concept, the convenience constructor is nothing more than a method that gets created inside of the object that returns an object of itself after running alloc and init. And whatever init you run is going to be the one that you're going to use to initialize the data members of the particular object. So it returns an object of itself. The interesting thing is now we see the plus sign. It's a class level method. It's not run on instances of the object, it's made to create the object. Instances don't exist at the time that we're running this. So think of it in C++, it's sort of like a function. Or in Java, if it's a class static, it's a function that we're running, not on the instances, but of the class itself. Kind of reminds me of an old function in C, as an example. So we run this function here, student with name, which is the name of that convenience constructor, and we just send it the parameters, and now we have syntax that looks more like C++ or Java. We don't have to do an alloc and an init, but we're still running a method. So I don't know, half dozen or others, I don't know how convenient this really is. But people like to do this because it cuts down, and if you're going to write the class once and you're going to use the class over and over again, technically you're writing fewer lines of code in main. If you're going to run the convenience constructor, that's going to construct everything for you automatically each time. So you don't have to rewrite all that code. Not that much, it's just 2 words, alloc and init, really. So we could have easily just alloced it right here. So the message is sent to the student class object. It's a class object, and returns a pointer to itself, and the pointer is assigned to student. So the calling code does neither an alloc nor an init, and the auto release pool must be in place in this particular example because we're using the auto. We're doing auto release. So if we're going to follow through with this, if we're going to allocate the old style way, then we have to do an auto release pool, and we have to create the pool in main before we do this. Otherwise, you leave those lines of code out in the current version, and you don't have to worry about that at all. Alright, so that was my spiel on the memory part of it, alloc and init and constructors, which was lecture number 2. So in lecture number 3, let me get rid of this one so I know which one I'm going to. We're going to fly through these because they're pretty small. I want to talk a little bit more about the initializers because we're going to see some of that now with inheritance coming up. So we're going to write an initializer later. Well, we've actually kind of looked at one yesterday, sort of wrote one. They all look the same as I mentioned before. So correct initializers have to comply with a few rules. What are the rules? They're really not rules. It's just categories of functionality that we're going to call initializers. So technically, the initializer name should begin with init, I-N-I-T. If you don't follow this, you're not technically writing an initializer. Doesn't mean you can't write another method that doesn't have an INIT in there that you don't run at the beginning. You can do that. You don't technically have to, but if you're going to call it an initializer, you're supposed to use INIT in the naming. It also returns the initialized object, which is self. So all initializers return self because what you're doing is you're populating the data and you're returning yourself with the data that comes out of it. So the initializer also calls the initializer of the superclass, which is that line of code we put in the beginning that says, run super in it. And then if that fails, don't continue. But if it passes and we got the super, let's create ourselves. So it becomes more of a template in terms of our initializer construction versus an afterthought. So this will, when we run the superclass initializer, we populate or propagate up the chain of inheritance until we finally hit the init of the NS object. Well, so far we haven't been working up the chain that far. We've only been working one level. So we've been thinking directly about NS object in terms of the init. Initializer uses the value returned by the superclass init, and initializer must consider Must consider and correctly handle construction errors. You know, to be proper, if we didn't return super, if super init fails, we shouldn't be creating ourselves, which is what that's saying. So in terms of our method syntax, and this is a little bit of review for you because we're going to review method syntax and then we'll look at initializers again with our source code examples. Remembering that we have the plus and the minus, and that the plus is class level, the minus is instance level. Our definition is preceded by these symbols, and return type is a CCast. So we actually, because everything is an object, it's a generic object, so when we return, this is really a cast. So it's like it's the same syntax as we use in C, it's a cast. Because Objective-C really is just a layer on top of C, if you think about it. So float is returned as the data type from the result, and if the method has no parameters, the definition and call consists only of the method name, which is this. So that's our method footprint, as we saw yesterday. So each parameter is also presented by a colon, as we saw yesterday, followed by the parameter type of the CCast, and here we have colon int parameter 1, or par 1. So I'm reviewing the syntax, by the way, so when we jump right into the code, I don't have to do this again. So if I review it again, sometimes people forget. It's only been one day. You know, it's hard to remember syntax. So method 1 colon int par 1 is the name of the method. The colon says we have a parameter. The parameter type is int. So before each colon, we can put a label, which we saw yesterday. And the labels become part of the method name. We have to use the labels. So we compare the two definitions below. We have one on the left and one on the right. This has labels. This has some. This is word wrapped, by the way. This piece here belongs over here. So if I made it smaller, I don't think it actually gets smaller. I think it just zooms in the same format. But this is the A and this is B. So in A, we have float sum, and we have A, B, and C. So the sum method takes on 3 parameters, A, B, and C, and hopefully would return the sum of those 3. Here, it's the same method. So you can write them the same way. They mean the same thing. They do the same thing. One of them is a little bit more expressive because we have sum of A and B and C added in there. If we write it like this, we have to call it sum of A and B and C when we run it, because we've made it part of the message, part of the method formats.
So can you just say sum A and B and C?
We can do this just fine. I like this better.
No.
Oh, over here?
Instead of A, just say sum.
You can type, oh yes, you can label it any way you want. You can go sum A, sum B, sum C, without saying and. The wording is completely up to you. In the examples I've shown you, I've used and A, and B, and C. You don't have to do that. Or with name, with age, with something or other. Usually programs will come up with their own. So you could do, actually, if I were doing this, I'd take out the ands. I'd keep the sum, and I'd go capital A, colon A, B, colon B, C, colon C. Then I'd write A is this, B is this, C is this. Instead of those ands in there. I mean, that's my own preference. I kind of minimize it a little bit. But yeah, no, the wording, you're naming it. So you can use only, it's like the same freedom you have when you create parameters in any other language. You can name the parameters anything you want, actually. Not a good practice to name them with the name of the actual data member, because then you have to worry about self then. Because you can't say name, we did this yesterday actually, call it name, call the parameter name, and then assign it to a name. Then you have to use more syntax if you really want to do that. And then here, if you say A, lowercase a with the A, it gets confusing. So what you're trying to do here, if you're going to do this method, you're doing it to clarify. You're doing it so that, you know, you're making it more expressive versus more confusing. So hopefully you'll keep along the lines of making it more expressive. Here's another example where we have the usage, so the example call with the definition. So here's our sum A, B, and C. We call it, you know, here's our object, and we're going to run sum. because we have A, B, and C on the right-hand side of the colon, nothing before the colon. We don't put anything before the colon. We run sum colon 1.1 space colon 2.2 space colon 3.3. And then that's our method call. Or that same function we just looked at a few minutes ago, if we call it with the and, so we have sum of A instead of sum, because this is what followed. This is what followed the colon over here, which is why we have sum of A. It's a different function. If we called it sum, it would be sum colon, and then NB is this one here, NB, and then C. Do you have to remember more? Sure. You have to. It's harder to do it this way, which is why I kind of do it this way. Leave out, just put the colons in here, and leave out the names of the parameters. But how am I going to remember this is A, B, and C? Or how do I know it's a string and an integer that I'm supposed to be putting in there? Don't know. This is a little bit more, help for the memory, so you can remember what you're supposed to be doing. They do the same thing, but the second one reads much easier, and that reads the details and explanation in the lecture notes. Well, I just gave it to you, actually, so you don't have to read it. So let's take another, yeah?
And the order which you pass in, it has to be...
The order has to be the same order, yeah. Oh, yeah. Which is actually kind of interesting because it follows the same rules as C++ and Java. You can't mix the order of the parameters, because if you do, you have a different method. Because you can, it's overloading and overriding, which is exactly the same as C++ and Java. So we can write multiple methods. If you missed the question, it was the order was the question he was asking about. If you change the order, you're calling a different method. So you can write 5 methods that are called sum of A, but they have different orders of their parameters. And then you can allow your programmer, or allow whoever's writing main, to supply different orders of those parameters. And then it's going to call a different function. The only problem is it's controlled by the data types. So it's going to be integer, 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 not sum A, sum B, sum B, sum A. The naming of it has got to match the parameters, and then the parameters have to be unique. Otherwise, you're going to create multiple of the same. So anyway, order matters, long story short. All right, so the initializers. Going back to the initializer concept and adding in the information we just gave it in terms of the method creation concept. Initializers with arguments, as an example here, we have in the Hello World class. Init with number and value. So init with number n and value v. Number is equal to n, value is equal to v, and then we're going to return self. The big difference is the return of self at the end. So returning self over here. So the return type of ID over here. So this is generic because this is a generic object type ID. So we return the type of ID. It's called dynamic typing. ID is the same as void in C, or void asterisk actually in C. So it's kind of like void asterisk, which is going to be it's a different than void itself because it's not returning empty. It's returning a type. It's a generic type. So now we can write ID HW is going to be equal to hello alloc init with number 3 and value 3.7. Because we have this up here, number 3 and value v. So n and v, n is going to be a number, v is going to be a float that we're going to work with. And assuming that n and v are data members of the class Hello World. And we're returning self, so we get an object of ourselves. So this is basically a review of how to write the initializer using parameters, kind of like what we did yesterday. Initializer is much better, but still not totally correct because we didn't put an error checking in here. We didn't check to see if self super was actually created. So we can modify this a little bit more by putting this line of code in here. So if we wanted to be all-inclusive in terms of our initializer rules, we would check to see if self is equal to super init and that super init returns something. So we call to alloc returns a new object. To this object we should send init by sending an inherited init to the parent class, and the initializer should continue only if the init succeeds. So in this particular case, init with number n and value v. If super is equal to super init, return nil. else, otherwise, we're going to continue. Because on this line, it would actually just return nil. So then we would be over with. Then we have self, and then we're using this here. You don't actually have to use this. You can use the dots. It works just fine. So self dot number is equal to n. Self dot value is equal to v. Return self. Which is the same code that we see up here, actually. So we don't actually have to put self anything in here, and we don't actually have to put the arrows. We actually use dots now. In the old days, this is old syntax. In the old days, we had to use the arrows. Now the dots and the arrows work. Yeah, yeah. If you remember yesterday, I did this with dots. I did self dot name is equal to name. So what ended up happening is that in the beginning, remember this comes from C. It's the earlier versions of Objective-C. If you're following C correctly and you're using a pointer, you have to use that arrow with a pointer object. And then people started using dots all the time. So where does this dot come from, right? And long story short, now both of them work. I prefer the dot, but see people prefer the arrow because they're, oh, it's a pointer. Let's put that arrow in there. The dot still works. So I did it yesterday with the dots without the pointer. You'll never see me using the arrows, although technically it's probably more correct to use the arrows. But I don't know. I'm following more of the modern day generation. Well, we're not considering this a pointer. Huh?
Can you explain that first? Like, why are we adding that one? The selfie.
We're adding this one as a measure of error checking. Because this one here didn't actually have it. It works just fine. But if we go back up to our pseudo requirements, and I say pseudo because it's not really a requirement, the third one down here says the initializer calls the initializer of the superclass. And then we want to make sure that we don't get an error message. We want to make sure that we are actually checking to see that the chain of events actually occurs correctly. And in order to do that, because we could have, let's say, for example, ran out of memory or something, if this didn't work, why are we creating an object from a super object that doesn't exist? So they put this in, and I think it's, you know, half a dozen or another. If you leave it out, it doesn't really matter, because actually you can leave out the whole thing and write your own method. It doesn't even do initializer. I mean, it's your choice. There's no fast rule that says you have to put that in there. It works with it or without it. But if you want to be syntactically correct, or you want to be correct in terms of the theory of the initializer, you want to make sure the parent got created. If the parent didn't get created, why are you creating a child out of that?
So if there is no more superclasses?
Yeah, if there's no superclass, why are you making a subclass? It basically is just checking to see if super exists. Because super should return to self. I got a super. And I'm like, great, now what do you do with it? Well, let me return myself now. Now that I got a super, now I'm going to assign myself, my name, my age, and all that stuff. Then I'm going to come back and say, hey, I'm done. I'm initialized. So the whole call now becomes more complicated, but it's explained in lecture. I just explained it to you, actually. When it says explained in the lecture, it means what I'm talking about right now. So, all right, so that's the last little send here. Sending the inherited init to the parent class. Now we have the new class. So if we create a class out of this, we have a student that's going to inherit from NS object, and we have a string, and we have a GPA. And here we're going to have two initializers. This is the default initializer init, and then we have an init student. So we're going to initialize it with student. We're going to give it a name and a GPA. So then in our class implementation, by the way, this is the interface that we defined. In the implementation, the .m file, that was the .h, we have the implementation of students. And student's going to have init in here, and the default init is going to be, this is the same method we just looked at a few minutes ago. And then we have init with students with, looks very similar, actually. In fact, almost looks the same. The only thing different is we're actually passing the parameters in. So for those people who like to write constructors, there should be an option in there that says generate inits. Generate setters. We don't have to generate setters and getters because we can use property and synthesize. But we really need like an Eclipse option that they have in Java to generate constructors. But this would be init, so generate inits. Anyway, long story short, that was supposed to be a joke. But if you don't know Java, it's past. If you've never used Eclipse with Java, you don't know that you can actually do all this stuff automatically with Eclipse. It's just menu options. So I was saying Xcode needs some menu options. Just create all this stuff for me, really, seriously. Anyway, so here's your two initializers. One of them is the default initializer. The other one is one that takes on two parameters. You can have as many initializers as you want. If you don't include init in the name, technically you're not writing an initializer. Will this work without init? Of course it will. It'll work. And can you call more than one? Yep, you can. We did it yesterday, actually. We called init, which was the default, without even implementing it, because we're going to run super inits. And then we ran init with a name and an address. We just ran it again. And then we can just run it again. It's a method call. You just run it again and again and again. Why do you want to keep initializing your objects? So you might want to reinitialize it with new data once you got it. But probably at that point, you're going to be running other methods. So the distinction between the initializer and the methods is a loose interpretation with Objective-C. Much stronger implementation of it with C++ and Java, because you actually have constructors that are actually part of the automation of the object creation. This is all manual, long story short. So, questions about initializers? Okay, let's go on to 4. So what I'm doing is reviewing with you, but I'm giving you the lecture part I didn't give you yesterday. So, but it's still, this time it serves as a review to kind of get you up on the same page from yesterday. Lecture number 4, we covered this as well. This is only 4 slides, don't worry. It's the derivation of runtime binding. So, derivation and runtime binding are the most essential parts of object-oriented languages. Well, we know the references we've been creating. Person P1, ID, my ID, whatever. Creating these references and then binding objects to those references. The derivation is the inheritance process, which is what we're going to be looking at next in terms of our source code. So the derivation is the syntactic mechanism for inheritance. Inheritance, by definition, is the semantic of validation, deriving one object from another. It expresses the meaning of the derivation. Derivation is a mechanism by the class, acquires methods and instances and variables of the other class over its superobject. So we saw this yesterday, but we didn't continue it, so we'll continue it today with employee and person. And I have some source code examples that we'll bring up to take a look at this. It's going to be in source code examples section 3, number 3. So if you want, before the internet goes down or we have problems, if you go into the Objective-C course, go into source code examples, just go ahead and get 3 and 4 right now if you can, before everybody else hits the internet to go do it and the internet goes down. So the lucky ones will get it first. So we're going to be looking at practice 3 and practice 4 next. Anyway, so back to the concept here. Inheritance is expressed when a new class's interface is declared. So interface grad student : student. We saw this with person and employee. We can add additional variables to it. So we have NSString major that we're going to add to it. And then we list the inherited methods that we're going to override. So we list new methods for grad student. For example, a designated initializer for grad student. So we add initializers to it. In this particular case, we're going to say name, GPA, and major. So init grad student with name and GPA and major. And the grad student here just has major. The student has GPA and name. So when we call it runtime binding, this is the decision during runtime by definition. Which method is going to be executed when an object is sent to the, when a message is sent to the object, which message is going to be sent depends on what object you're working with. So it's all dynamic. So the execution message depends on the type of object. If we have a reference type as a grad student, they're going to get the grad student messages. If we reference it as a student, it'll get the student messages. It's kind of like virtual in C++, except we don't have to use the keyword virtual. We don't have to use it at all. It's automatically done for us. So it's better than C++ in this respect because we don't have multiple copies. We just get whatever is referencing it as. then we get it. And then we can cast the object clearly back into the other version of the object, reference it as the other version of the object, and get that object's methods. In virtual, you don't have to know this, but in virtual, you get whatever is the last reference. You don't get multiple copies, you get whatever it is you intended to do through the derivation process. You make it virtual so it doesn't really exist, and then you implement it. Pure virtual implements only the last version of it that actually gets created. Here it's dynamically runtime. So we have it dynamically created when the object changes. So if the object changes back into a different form, we have that other method over there that belongs to that other form, and we run that one instead of this one. So we have more dynamic behavior in Objective-C than we have in C++. It's equivalent to Java. Java is more dynamic. Java is 100% dynamic. Objective-C is 100% dynamic. C++ is hybrid, partly static, partly dynamic. And there's all these rules that you have to play around with to get the right method to work. Here it's just given to you. It just works anyway. So it's just like Java in that respect. Don't understand those other languages, don't worry about it. Just remember everything is dynamic in Objective-C. So the message can be sent through the typeless pointer, and the pointer that we're going to use here is the ID pointer. So I have an example where we can create a couple of objects, make them IDs, use them all together as a typeless pointer, get rid of the type completely. Whatever the object is, whatever that method is associated with that object will just naturally just run for us. So we're going to see that in one of the examples coming up. All right, so do we want to break or do we want to continue? Break? Oh, jeez, that wasn't unanimous. Let's take a bio break because I know some of you have been sitting here since 9. So let's take a bio break. So let me stop this and then we'll start in with inheritance examples and source code writing next.